Hello. So in this one, we are, shockingly, taking a derivative. But here we have a quotient, right? So we're going to be needing to use the quotient rule. So as a reminder, the quotient rule, right? So we're going to have, if you want to take the derivative of some f of x over g of x, well, that's going to be, right, now I have to be careful about the ordering because I'm going to have some non-commutative stuff going on. So that's going to be the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Okay, so here we have to be careful because we have subtraction, that's not commutative, and we have division, that's not commutative, so I got to make sure I put the stuff in the right order or I will legitimately get an incorrect answer, right? All right, so I guess might as well go, right? So we have the top, that's x plus 7, and the bottom, that's x cubed plus 3x minus 1. So the first thing I'm going to do is just sort of plug in to my quotient rule here. So I'm going to get the bottom, that's the x cubed plus 3x minus 1 times the derivative of, so I'm just declaring I'm going to take a derivative. I'm not going to do it quite yet. So this is x plus 7 minus the top, x plus 7, times the derivative of the bottom, that's the x cubed plus 3x minus 1, all over the bottom, which is that x cubed plus 3x minus 1 squared. Okay, so I plugged in my formula, right? The low d high minus high d low all over bottom squared. So now I'm going to actually do the derivatives that I need to do, right? And these are just polynomial rule. So I'm going to get x cubed plus 3x minus 1 times, so here, derivative of x plus 7, so the constant goes to 0, so the derivative kills that off. Derivative of ax is just a, right? The derivative of something times x, you take the 1 down, and the x part goes away. I'm just going to get a 1. Now I still have my x plus 7. And here, I'm going to get 3x squared. So that's going to give me 3, and minus 1, the 1 goes away, all over bottom x cubed plus 3x minus 1 squared. And it really doesn't matter if I use parentheses or brackets for that, right? So I switched, but it doesn't make a difference. Now, I could expand this all out and get sort of combine like terms, get a more elegant answer, but there's no sort of reason for me to do that, right? I don't need to solve when this equals something or find a particular value or any of that. So unless you sort of have instructions otherwise, either globally, like if your TA always wants you to simplify, or if you're trying to do this as part of another part of a problem and it needs you to sort of simplify to move forward, obviously you should do it in those cases. Here, I can just stop there, okay? So that is that. Hello. So, shockingly, another example video, we are taking another derivative. So this one again is going to involve a quotient for a quotient rule. But in this case, we also have an exponential going on. So again, if you haven't seen exponentials and don't know how to do the derivative rule, you wouldn't have to worry about seeing those yet. This video is sort of intended for those that are reviewing product rule after they've seen exponential. So that being said, let's recall our product rule. So, quotient rule. So we have, if we want the derivative of f of x over g of x. So this is always a good idea to write down the rules that you're going to use so that you sort of make sure you did them correctly, right? So you have sort of a reference. So this is going to be low d high minus high d low all over bottom squared. Okay. So this is what I'm going to do. So I'm just going to go ahead and write it out. So here, my top, right, my high, my f in this parlance is x plus 7. My low is x to the minus 3 minus e to the x. So I'm going to start by writing out the low. So I'm going to have x to the minus 3 minus e to the minus x. That's low. And then I'm going to take the derivative of, so I'm just declaring that here. I'm going to take the derivative of the top, that's x plus 7, minus the top, x plus 7, times derivative of the bottom. So that's the x minus 3 minus e to the minus x. Sorry. I was like, wait a second. I said a thing and wrote a thing, but I think I did it over here too. Yep. So too many negatives. Sorry. Always a good idea to go back and double check that you've written it correctly. In fact, that's usually what I'm doing when I stand off to the side and explain some stuff. I'm secretly doing that as well to make sure I didn't mess anything up. X minus 3 minus e to the x all squared. Okay, so when I'm over here, explaining what I did, I also read through to make sure I didn't make any mistakes. Good plan for you to do as well. So I took the bottom, right, that x to the minus 3 minus e to the x, and then I declared I'm going to take the derivative of the top, haven't done it yet. So that was the x plus 7, right? So that's what this will become. Then I have minus the top, x plus 7, times the derivative, which again I haven't done that yet, but will be derivative of the bottom all over the bottom squared. So now I'm going to go ahead and do that. So I still have this. So I have x to the minus 3 minus e to the x. Derivative of x plus 7, so the derivative of x is 1. Derivative of 7 is 0. So this is just 1. Minus, so then I'm going to have x plus 7. Derivative here. So here I'm going to pull the negative 3 out front, then subtract 1, so I'm going to get x to the negative 4. And here I'm going to have minus, and the derivative of e to the x is itself. It's that special nice function, right, the super function, for calculus anyway, all over the bottom x minus 3 minus e to the x squared. And again, I could try to multiply this all out and try to simplify, but there's no reason to do that here. But you might have a reason in your work to do it, so keep in mind that's sort of a natural follow-up that might happen. I don't need to do that here, so I won't. Okay, so that is that.